Hey everyone, today we're going to discuss about logarithmic and exponential equations. So in this topic, we will solving for the values of unknown variables involving logarithmic and exponential equations. So an exponential equation is an equation whose variable occurs in the exponent. An example would be 3 raised to x is equal to 5. This is an exponential equation. The second kind of equation that we're going to deal with is the logarithmic equation. A logarithmic equation is an equation containing a variable in the logarithmic expression. An example would be logarithm of x to the base 5 is equal to 2. So there's a variable which occurs in the logarithmic expression. So this is a logarithmic equation. Now, in dealing with the logarithmic and exponential equations, we have this what we call the one-to-one property that we can use to solve for exponential equation. Now, the one-to-one property of an exponential equation can be used in solving for the solution of an exponential equation. This states that if b raised to x is equal to b raised to y, then this means that x is equal to y. If we have two expressions of the same base is raised by x and y, and we say that they're equal, this means that the exponents x and y themselves are equal. We'll be using this later on when we solve for logarithmic and exponential equations. So let's have some example here. We have 5 raised to x is equal to 125. So our objective here is we'd like to know what is the value of x, which makes this equation true. So we can see here that we have 5. It is raised by a particular number and it is equal to 125. At first glance, we would know that since 125 is 5 cubed, we'd know that x is 3, right? But how are we going to express our solution for that? So we will be applying the exponential equations. So we have 5 raised to x. The thing that we do here is we will write 125 as a perfect fifth power. Take note that this is not always possible. We only do it if it's possible. And in this case here, it is possible for 125. Take note that 125 is 5 cubed. So we will write 125 as 5 cubed. So next, we've seen here that 5 raised to x is equal to 5 cubed. They have the same base, but one is raised by x and the other one is raised by 3. So by using the one-to-one property, we can conclude here that the exponents themselves are equal. So x is equal to 3. So this is our equation, or rather this is our answer. X is equal to 3. Next, let's have this equation here. We have the logarithm of 3x plus 1 to the base 3 is equal to 3. So let us solve for x here. So what we can do here is we can rewrite these logarithmic equations into an exponential equation. Take note that that often happens when we're dealing with logarithmic equations. We try to solve them as exponential equations, and if possible, we just apply the one-to-one property. Take note that we only do it if it's possible. So what we're going to have here is we take the base. Let's write this equation into an exponential equation. So this becomes 3. This is the base. The exponent is 3 as well. So 3 cubed is equal to 3x plus 1. And 3 cubed is 27. So 27 is equal to 3x plus 1. Let's transpose the 1 to the other side. So this becomes 26 is equal to 3x. After that, let us divide both sides by 3. This means that x is equal to 26 over 3. So this is our final answer for the value of x in this expression. X is equal to 26 over 3. Now take note that not all logarithmic equation or exponential equation can be solved manually. There will be cases where we might have to use a calculator. Like in this scenario, we have 5 raised to x is equal to 10. So 10 here is not a perfect fifth power. So we cannot express it in a perfect fifth power. So we cannot use the one-to-one property here. So what we can do here, we will get the logarithm of both sides here. Logarithm of 5 raised to x is equal to logarithm of 10. Then let's just express the value of x into the nearest possible value that we can get. Since here we have an x here which is a power, we can use the logarithm of a power here. We put the x as a coefficient. So this becomes x logarithm of 5 is equal to, remember the properties of a logarithm, logarithm of 10 is equal to 1. Take note, the base here is 10. It's a common logarithm. So x logarithm of 5 is equal to 1. So let's divide both sides by logarithm of 5 to isolate the x. So this becomes x is equal to 1 over logarithm of 5. So that's the nearest possible value that we can obtain. From here, we will be using a calculator since log of 5 is not an exact value. So that's how we go around in solving for the value of x in a logarithmic and exponential equations. So in our next video, we will be discussing about inequalities this time. So I hope you guys learned a lot. Thank you guys for watching and see you guys in the next video.